first statements or first questions are going to be, can you condense this statement from a few logs to one log? Anytime we have a number in front of the log, it becomes an exponent. Think of the reverse. When it's an exponent, we throw it to the front. So this becomes log base 2 x squared plus log base 2 y cubed, and the plus sign means we multiply. So we get log 2 right there, x squared y cubed. Addition means multiply. Okay? For our second one, we're going to multiply due to the addition sign, and that's going to be 28x, with the 3 as middle subscript there, minus log, and we always have to have the common subscript, okay? And then the subtraction sign represents division, so it's 28x over y. So once again, we're trying to get a few logs to be going down to one log. And then here, the ln's, we have ln 3 to the 4th plus ln 7 squared. And we want to actually do that math out. Okay? 3 to the 4th is 81. 2 to the 7th, or excuse me, ln 7 squared is 49. And the 81 times 49 is 3969. And that's our answer. We can have a big number like that. That is okay. All right. So now our second page is going to be, instead of condensing, we're going to expand. The rule of thumb here is each term gets its own log. So log 3x plus log 3y. These multiplication can be translated into addition between logs. And the division of C is subtraction. And that's just understanding multiplication represents division with the log. I'm sorry. Multiplication represents addition with the logs. Subtraction represents division with the logs. The second one, I'm going to get that exponent in front first. So it's m over p squared, and then log m squared over p squared. And we finish with the division there, log 5 m squared minus log subscript 5 p squared. And that's our second page of expanding the term. So we have to condense them, get a bunch of logs or our natural logs into one term, or expand them where we take one log and expand it into multiple terms where each term gets its own log. Now when we're solving for x, we're following these same rules, and then we're solving for x. The top two, when we multiply, we get 40x equals log 4, 80. And when I have the same logs with the same subscripts, I just set these two terms equal. 40x equals 80, and my x equals 2. And you can absolutely plug them back in and check your work with that. With subtraction, it's log 3. All right, we have 28 over x minus 5 equals log 3, 4. And these two terms have to be equal. 28 over x minus 5 equals 4. We multiply both sides by x minus 5. And we get 28 equals 4x minus 20. We get 48 equals 4x, and my 12 equals x. On the bottom, we're going to multiply as instructed by the positive sign there, and that becomes x squared plus 4x equals 1. There's no log on that right side, so I can't just imagine it. But 5 raised to this exponent should equal the x squared plus 4x. So x squared plus 4x should equal 5 to the 1. The subscript raised to the number to the right equal sign equals this number right here. Okay? So 5 to the 1 is 5. And yes, you're going to get some factoring here. I'm going to subtract the 5 over. I want to set it equal to 0. And we get x plus 5 times x minus 1 equals 0. We get negative 5 and 1 is our answer. but only the positive answer qualifies. You can't have a negative in the term right after the log. All right, so you can't have a negative 5 in there. Therefore, the only answer there is 1. With division, we're going to do 5x plus 5 over 2x minus 1 equals 1. And therefore, it's a 3 to the first power. So 5x plus 5 over 2x minus 1, that equals 3 to the first power. We're going to multiply 2x minus 1 on both sides. And that leaves us with 5x plus 5 equals 6x minus 3. We subtract 5x, we get x on both sides. We add 3 and we get 8. And my x equals 8. And you can plug any of those back in to check them. Now, kind of the meat and potatoes of why we use logs, and that is to solve when there's variables in the exponent. Obviously, you do need to use your Desmos calculator to do these problems. This is not a problem you can do in your head. We're going to initially just put the log 5x equals log 38. Remember, when we condensed, we took the exponent in front and threw it back up. Now we're going to throw the exponent to the front. X log 5 equals log of 38. And my answer is x equals log of 38 over log of 5. And when I plug that into my Desmos calculator, log of 38 over log of 5, my x becomes 2.26. Same deal on the second one. Log 2 to the x plus 2 equals log 15. Notice I'm doing the same thing to each side of the equal sign. We throw the exponent in front. So x plus 2 times log of 2 equals log of 15. X plus 2 equals log of 15 divided by log of 2. And then x equals a negative 2 plus log of 15 over log of 2. And when we plug that into our calculator, we get x equals 1.91. When you're not given a variable, we just want to solve log 7, log 38. Excuse me, log 738. We're literally just taking the number that's not the subscript, putting it with a log, and putting a log with the subscript and dividing. Log of 38 over log of 7 is 1.87. Log of 72 divided by log of 4 gives me a 3.08. Moving right along. Now we're going to be using e's and using ln's to solve our problems, or natural logs, I should say. When you have an e, you're going to use a natural log. When you have a natural log, you're going to use an e. So obviously here we have to get the e alone first. So 4e to the x equals 44, and e to the x equals 11. And now I do the natural log of e to the x equals the natural log of 11. When you take the natural log of e, you're just left with your exponent. X equals the natural log of 11, and your x is 2.40. Remember, we're always rounding to the nearest hundredth. Second one, 3e to the 4x equals 39. We're dividing 3 on both sides. E to the 4x equals 13. And I'm taking the natural log of both of them, which leaves me with 4x equals ln over 13. And I have to solve for the x, so I divide both sides by 4. My x is equal to the natural log of 13 divided by 4, and that is 0.64 for my answer. Now, when you have a natural log with the x, now we're going to be using e to solve the problem. We're going to divide the 5 out right away. Whoops. Ln x. Sorry about that. I don't know why that happened. Bear with me 1 second. There we go. So we have ln x equals 9. And then we take e to the ln x, e to the 9. So therefore x equals e to the 9th power. E to the 9th power is 8,103.08. And yes, you can have numbers that high. That's okay. Second one, ln to the x plus 2 equals 5. We divide 6 on both sides. We raise e, or take e and raise it to the ln, x plus 2, and then there's e to the 5th. We're left with just the exponent equals e to the 5th. And my x is negative 2 plus e to the 5th. And that answer is going to be 146.41. All right, finally, we'll take a look at the best real-life application of these problems, and that is the compounding or continuously compounding interest using the equation total amount equals our P, which is our initial principal, the number E raised to the rate times time. We're literally just plugging in 6,000 times E raised to the 0.04 times 7. So it's really 6,000 E raised to the 0.28. When I plug that into my calculator, E to the 0.28, E raised to the 0.28 times 6,000, I'm going to end up with a number of $7,938.78. If I want the length it would take to double my investment, as in the second problem, doubling a 2,000 investment means you get 4,000. My initial amount was 2,000, and in this case, I'm getting a rate of 0.09 or 9%, and I'm multiplying it by that time. When I divide 2,000 on both sides, I get 2 e to the 0.09t. And once again, we're solving when we're using e to solve for a variable, we need natural logs. ln2 equals ln e to the 0.09t, which means my ln2 is going to equal 0.09t. And then ln2 divided by 0.09 is equal to my t. And my t would be 7.7 years. So it would take somewhere between 7 and 8 years to double that investment. All right, guys, that is the review for the test that we'll go over in class as well. Good luck.